The AI revolution is here, and it is hungry, like insatiably hungry for power and for resources. So you've got to ask, what if the solution to AI's biggest problem on Earth isn't actually on Earth at all? This single question is driving one of the most incredible, most ambitious ideas of our time. I mean, to fuel AI's growth, we are pushing our power grids to the absolute breaking point. But a handful of pioneers, they're looking up, not for inspiration, but for infrastructure. So to really wrap our heads around where this is all going, we first have to look at what's happening right now, today. Because it turns out, AI is no stranger to space. In fact, it's already up there, managing the ridiculously complex traffic in orbit right above our heads.
And look, this is not some far-off science fiction concept. As Gabriel Omi from Spire Global points out, AI is basically the mission controller for these huge satellite constellations right now. It's the brain that's juggling all the signals, all the scheduling, and that lets these networks run with mind-boggling efficiency. It's a real-deal business tool.
And it's doing so much more than that. I mean, think about it. From routing our data through space to automatically dodging space junk in an orbit that's getting more crowded by the day, AI is crunching just mountains of weather data for better forecasts, and it's helping us analyze images of our own planet. The goal for a lot of these companies is what they call zero-touch operations, basically letting the AI handle all the routine stuff so the humans can focus on the big picture.
Okay, so AI is already a huge help up in space. But back here on the ground, our own demand for AI is creating a really serious problem. It's what you could call a twin crisis of data and power, and it's forcing us to get creative. All right, here's problem number one. Our satellites are collecting an absolute fire hose of raw data, 24/7. But trying to send all of that data back down to Earth is like trying to drink from that fire hose with a coffee stirrer. It's a massive bottleneck. What we really need are the insights, the answers, not the terabytes and terabytes of raw files.
And here's the second problem. And frankly, this one's the real monster. Just look at this chart. Data centers could be gobbling up over 9% of all US electricity by 2030. That's more than double what they use today. And AI is what's driving that surge. Our power grids are already feeling the strain.
Okay, so we've got a data traffic jam up in space, and we've got an energy crisis down here on Earth. Two massive, separate problems. But what if? What if you could solve both of them at the same time, with one truly elegant idea?
Enter the space-based data center. It's a beautifully simple concept when you think about it. Instead of beaming all that raw data down to power-hungry computers here on Earth, you just send the computers up to the data, right next to a literally unlimited source of solar power.
Let's just break this down. Here on Earth, data centers don't just use a staggering amount of electricity, they also need enormous quantities of fresh water for cooling, which puts a huge strain on local resources that are already stretched thin. And this is where the orbital advantage just becomes so obvious. In space, you've got solar panels soaking up sunlight almost 24/7. No clouds, no atmosphere in the way. And for cooling, well, you got the biggest, coldest refrigerator in the universe, the freezing vacuum of space itself. Absolutely no water required.
The other problem we have on Earth is, ironically, a lack of space. To build a gigawatt-scale data center, you need huge amounts of land, and you have to navigate a complete nightmare of permits and regulations. It's slow, it's expensive, it's complicated. But up in orbit, there are no neighbors to complain, no zoning boards to appease, and, well, there's a virtually unlimited amount of physical space. You can, in theory, just keep adding on, scaling up to meet whatever demands AI throws at you.
So, I know what you might be thinking. This all sounds incredible, maybe a little too good to be true, like something straight out of science fiction. So why is this happening now? What's changed to pull this idea from the drawing board into actual business plans?
Well, it's really a story in three parts. It's a perfect storm of breakthroughs. First, back in the 2010s, reusable rockets came along and completely shattered the old cost of getting to space. Then, in just the last few years, we've built a real data backbone in orbit with satellite internet. And all of that leads us right here to 2025, where companies are launching the very first computing hardware built for orbit.
And honestly, this is the key that unlocks everything. Just look at these launch costs. We've gone from tens of thousands of dollars for a single kilogram down to just a couple thousand. And with what's coming next, like Starship, the goal is to get that down into the double digits. This isn't just a small improvement, it's a total economic revolution. All right, so the tech is finally here, and the economics are starting to make sense. So, who's actually building this future? Let's meet some of the pioneers on this new digital frontier.
You've got a few key players leading the charge, and they're each tackling a different piece of the puzzle. Think of it like this. You have StarCloud, and they're building the brains, these massive AI training clusters. Then you've got Axiom Space, who are building the home for those brains on the first commercial space station. And finally, you have Kepler, who are building the nervous system, the high-speed internet that connects everything up there.
And just listen to the sheer ambition in this quote from StarCloud. This isn't about offloading a few servers to make things a little easier. They are talking about moving the entire future of large-scale AI development off planet, where it can grow without all the limits we have down here.
And they are not messing around. Their very first demo satellite is set to launch with NVIDIA GPUs that are over 100 times more powerful than any GPU that has ever been operated in space, ever. That's not a small step. That is a monumental leap forward.
So let's just zoom out for a second. Where is all this heading? What are the really profound implications when we start to seriously think about AI's future as being, well, off-world? I love this analogy from one of the industry CTOs. It's the perfect way to reframe what a modern satellite is. It's not just a camera or an antenna anymore. It's a full-on edge computing device, a server rack with solar panels hurtling through the void at 17,000 miles per hour. And that brings us to this final, really provocative question. As we build these massive AI clusters in orbit, powered by the sun and cooled by deep space, we really have to ask ourselves, what happens when humanity's most powerful intelligence no longer lives on Earth? That's a wild thought, and it's for a future that we're building right now. Thanks for digging into this with me.